We're going to continue chapter 11. Now we are in section 2, the gas laws. Scientists found that there are three factors affecting gas: pressure, temperature, and volume. And if we want to study the relation between any two factors, the third factor must be constant. So if we are going to study the relation between two factors, we are going to fix the third factor. The third factor is a constant. So one of them will be constant, and we are going to study the relation between the other two. The first law is called Boyle's law. Boyle studied the relation between pressure and volume, and he discovered that the pressure and the volume of a gas are inversely proportional. The pressure of the gas and the volume of the gas are inversely proportional. Why? This can be explained by the kinetic molecular theory. The pressure of the gas is caused by moving molecules. The collision between the moving molecules is the pressure. As we said before, that the gas molecules are in constant motion, and as they move, they collide with each other and they collide with the container walls. So when they collide with the container walls, this is the pressure. So if the volume of the gas decreased, if we decreased the volume, the space which the particles are in, the particles will be closer together, and this means more collisions between the particles. So the pressure will increase. So decreasing the volume, decrease the space, so more collisions and the pressure will increase. And if the volume of the gas is increased, so the particles are farther apart, so will be less collisions, and this means the pressure will decrease. So Boyle's law studies the relation between pressure and volume. So the pressure of a gas and the volume the gas occupies are inversely proportional. So if you keep everything else constant, then as the pressure on a gas goes up, its volume goes down. And as the volume a gas occupies goes up, its pressure goes down. So if you exert a pressure on gas particles, we can compress it, making it taking less space, lower volume. So imagine we have a hard container. If you make the container smaller, if we decrease the volume of the container, which means the particles will occupy less space, so smaller volume. The particles will collide with each other and with the container walls more, which means higher pressure. And if we make the volume of the container bigger, increasing the volume, the particles will collide fewer and there will be fewer collisions, which means less pressure. Yes, less pressure. So Boyle's law, the pressure and the volume are inversely proportional. So Boyle's law states that the volume of a fixed mass of gas inversely with the pressure at constant temperature. The third factor is constant, which will give us this relation. B1 V1 equal B2 V2. B1 and V1 represent the initial condition, the condition of the particles before decreasing or increasing the volume. And B2 and V2 represent the final condition. So now let's solve a sample problem on Boyle's law. A sample of oxygen gas has a volume of 150 milliliters. This is V1, when its pressure is 0.947 atmospheric pressure. This is B1. What will the volume of the gas be, the final volume, V2, at a pressure of 0.987 atmospheric pressure? This is B2, if the temperature remain constant. So the given are B1, V1, and P2. We are given pressures and volume, so the relation is between pressure and volume, which is Boyle's law. So B1 V1 equals B2 V2. B1 V1 B2 are all given, and we want to calculate V2. So B1 V1 B2 V2. So the volume of the oxygen, the final volume of the oxygen will be 144 milliliters. Now we are going to study the relationship between two factors, the volume and the temperature. A scientist called Charles, studied the relation between the volume and temperature, and he found that the volume and temperature are directly proportional. So when the temperature of the gas increases, the volume increases, and vice versa. The temperature decreases, the volume decreases. Why? If we heated a gas, if we increased the temperature of the gas, this means that the gas particles will move faster. And if they move faster, this means they will collide with the container walls more and more and more, and with more force. So they will push the container walls. So the container must be flexible, so the volume cannot change. So the volume of a flexible container will increase, and the pressure will remain constant. How? Let's see. Charles' law. Charles found that the volume and the temperature are directly proportional. So if the volume increase, the temperature increase, and vice versa. So the temperature and the volume are directly proportional. So keeping everything else constant, as the temperature of the gas goes up, its volume goes up. And as the temperature of the gas goes down, its volume goes down. So if we heat up a gas, the gas expands. Then the gas particles will move faster and they take up more space, the volume. Imagine we have a balloon that expands when the gas particles collide with the sides. Increasing the temperature makes the particle move faster, and they will push on the side of the balloon, expanding it, increasing the volume. Now if we cool it, this means the particles will slow down and the balloon will contract, so decreasing the volume. So the relation between the volume and temperature is directly. So now Charles' law states that the volume of a fixed mass of a gas at constant pressure varies directly with the Kelvin temperature. The temperature in this relation must be in Kelvin. So if in any problem the temperature is given in Celsius, we must convert it to Kelvin. How? The Kelvin equal 273.15 plus Celsius. So the temperature and the volume are directly proportional. So V1 over T1 equals V2 over T2. V1 and T1 the initial conditions, and V2 and T2 are the final conditions. So let's solve a problem. A sample of a neon gas occupies a volume of 752 milliliter. This is V1 at 25 degrees Celsius. The first temperature T1 but in Celsius. What volume will the gas occupy? He wants V2 at 50 degrees Celsius, T2 but in Celsius, if the pressure remains constant. So the given are V1 752 milliliter and T1, which we will convert it to Kelvin, plus 273.15, and T2, which we will convert it to Kelvin. The relation is between the volumes and temperature, which means Charles' law. V1 over T1 equal V2 over T2. V1 752, T1 298.15, and T2 323.15. Now we can calculate V2, which will be 815 milliliter. Now the third and the last relation or law, which is Gay-Lussac's law. He studied the relation between pressure and temperature, and he found that the pressure and the temperature are directly proportional. So if the volume is constant, the third factor is constant, the pressure of the gas increases, the temperature will increase. Why? Gas pressure is the result of the collision of the molecules, as we already said. As the particles or the molecules of the gas collide with each other, this exerts pressure. This is the pressure of the gas. So if we increase the temperature, we heated the gas. The velocity of the particles will increase. The particles will move faster, which means that the particles will collide with each other more, which means the pressure will increase. So Gay-Lussac's law is the relation between pressure and temperature. So the pressure and temperature are directly proportional. So when we keep everything else constant, as the temperature of a gas goes up, its pressure goes up. And as the temperature of a gas goes down, its pressure goes down. If we heat up a gas, the gas particles will move faster. So if the gas is in a solid container with fixed volume, the volume is constant. Increasing temperature, the particles will move faster and they will collide more with the container walls, increasing the pressure. But if the temperature is decreased, we cooled it down, the particles will move slower and it will be fewer collisions, which means lower pressure. So Gay-Lussac's law, the pressure and temperature are directly proportional. So Gay-Lussac states that the pressure of a fixed mass of gas at constant volume varies directly with the Kelvin temperature. The temperature must be also in Kelvin. So the relation will be B1 over T1 equals B2 over T2. So B1 and T1 represent initial conditions and B2 and T2 represent the final conditions. Now the combined gas law. If you want to combine the three laws, Boyle's law, Charles' law, and the Gay-Lussac law, in only one single equation, that can be used for situation in which temperature, pressure, and volume all vary at the same time. There is no constant factor here. The temperature, pressure, and volume all varies at the same time. So we are going to combine B1 V1 equals B2 V2, and V1 over T1 equals V2 over T2, and B1 over T1 equals B2 over T2 in only one single equation, which will be B1 V1 over T1 equals B2 V2 over T2. So here we have a problem. A helium-filled balloon has a volume of 50 liters, which is V1, at 25 degrees Celsius, which is T1, but we are going to convert it to Kelvin, and 1.08 atm, which is B1. What volume he wants V2 will it have at 0.855 atm, which is B2, and 10 degrees Celsius, which is T2, but we are going to convert it to Kelvin first. So the relation is B1 V1 over T1 equals B2 V2 over T2, and I'm going to write each one, B1 V1, T1 B2 V2 T2, and now we can calculate the second volume or V2 from this